Hello, welcome to another tutorial. Today I want to quickly cover something that's pretty basic but can be quite powerful, which is setting up look-at cameras. Setting up cameras that can observe things in the world if you need to have an external one that tracks something. Let's jump in. Okay, so the first thing that I'm going to do is create a new actor blueprint, and I'm actually going to make this a child of camera actor. And we'll do that, and let's call this look at camera. So what do we want to do? Well, the first thing we probably want to do is have a variable for our target actor. So let's go target actor, and we'll make it an actor reference. Okay, and we can drag that in, get that. Now, what we need to do is work out what the rotation that we want to have the camera set to look at the thing is. So the first thing I'm going to do in begin play, I'm actually going to set this target actor. So I'm going to tell it what I want it to look at. In this case, I'm going to get the player pawn. Okay, and we'll plug that in. So when the game starts, it's going to set my target actor to be whatever the player is. And then what I need to do is get the camera, grab it, and set its world rotation. Set world rotation. And we'll plug that into the tick. Now, what I'll actually do is make a custom event, and I'll call it update camera look at. And I'll actually plug it in there because I want to get into the habit of breaking these out either as a custom event here or as a function. So update camera. Let's make one here called distance, and we'll get to that in a minute. That's going to be handy. But what I want to show is that off the tick we can drag and type update, and we'll update the camera look at first, and then off of that we'll update the camera distance. Right now neither of those are necessarily going to do anything. Although actually the set world rotation is going to do that. So if I compile and save that, and then let's say come over here maybe, near where we start, and here's a cute trick. What am I talking about? We'll create a camera here in the viewport, and then with our actor selected in the project view, we can right click and choose replace selected actors with look at camera. And it keeps its name, but it's now pointing to the look at camera blueprint, which is fantastic. So to quickly check this out, now normally in order to switch to this camera, we would have some event in our game that took place based upon information if the player interacted with something, or if some moment is happening, or they've entered a certain trigger zone or something like that. Actually, that could be interesting. We might do that later on. But for now, I'm going to do the dreaded, horrible thing that I hate, which is use the level blueprint. So I actually already have an example here that I've done previously, but let's just do it from scratch here. Alright, so if I hit the U key, I want to get the player, I think it's the camera manager we need to get to set the view target with blend. No, it's actually the controller, because the controller itself communicates with the player camera manager. So we get player controller, we drag off of that and set view target with blend, not view tart. Set view target with blend. Now this is looking for an actor. So one thing that trips some people up is that they think they can just grab a camera component from anywhere and plug it in here. You actually need to specify an actor that has a camera component within it. So what we'll do is jump back into our level. We have our camera selected here, so let's rename this. How have I forgotten how to rename? Double click. Yeah, there we go. Look at camera 1. There we go. Why not? We'll leave it like that. And then if we right click in the level blueprint, we can create an explicit reference. Explicit references are bad. Do not want, don't like them, but we'll use them for this example anyway. We can set a blend time, which controls how long it's going to take to interpolate between the position that the current camera is at and the one that we want to switch to. So this is good for kind of soft blends. If you have a multi-state camera on your character that needs to switch between different cameras that have different behaviors, this is a really interesting, cool way to do it. We have the type of blend that we want it to do, whether it's linear, meaning that it starts moving at a consistent rate and stops, so it's very kind of rigid, very mechanical, or we have like cubic, easing in and easing out, ease out only, or ease in and out, all that good stuff. So basically the animation curve that it's going to use. We've got the blend exponent, so we can scale that curve based upon this number, and we can lock the outgoing one. So it'll fix, if that camera was moving and we didn't have this ticked, it would be kind of trying to interpolate between its current position and the new one while it was still moving. So we might not want to do that. But generally speaking, if you, like I said, if you've got a multi-state camera, you probably still want to be inheriting a little bit of that motion or rotation as it goes. Anyway, that's not the point. If I hit the U key, we will now switch to that camera, at least in theory. So this is my Hulse example. I can ride around and do my thing, and then if I hit U, I switch to this camera. But hey, I hear you say, this is not pointing at the horse. That's not what we want. It's just pointing straight out into the distance, and that is because we're not giving it a rotation yet. So what we need to do is get the location, get actor location of the thing that we want to look at, and then we can get the location of the camera component itself. That's a good way to go, get world location. And then we want to find the look at rotation. Find look at rotation. So we want the rotation to draw a line between this position and that position and work out what the angle is, and then pass that to the camera. So we'll pass that in there. We want it to start at the position of the camera, and we want it to end at the position of the target. So we'll hit compile, save, and let's just make sure that we're actually calling it. So update camera look at is going to go, hey, down here to custom event, hey, do this thing. Beautiful. So now if we hit play, let's say I'm running along as my Hulse. If I hit U, oh, it's chasing me. I can see it happening now. Yeah, go horsey. Yay. Super exciting. Oh, he's moonwalking. That's awesome. Awesome moonwalking horse. Sick, sick stuff. Cool. That's fundamentally it. That's how we set the rotation of the camera to be the look at rotation between the position the camera is at and the target. So what about if we want to have it do something else? What was the other example? Update camera distance. Okay, here we go. Let's open this one up. Let's get this function, and we'll get the target actor. We'll get that, and then we'll get the camera component, and then I think we can distance, get distance 2, and we want to get actually, yeah, no, this will just simply, because this is expecting actors, it's going to use self, which is this camera actor, and the target will be the other actor. And then we'll return that value and we'll promote it to a variable, and we'll call this target distance. Bam. Now that we have that, oh man, we can do so much stuff with this based on target distance. Oh, it's cool. So let's put a print string on the end of here, and we'll plug target distance in there. No, hang on, we'll drag it out, we'll get it, and we'll pass it in. It'll convert it to a string. Compile, save, man. Play. Alright, actually, I want to go into my horse and just quickly disable that thing. I don't edit these videos, so I'm sorry if they go on a little bit long. Alright, so right now we can tell that the horse is about 3,000 units away, and if we hit U, we can actually see it. So let's work out what the maximum distance we want this camera to be able to look at the horse from is. Let's say that it's about 4,000. So that's where it's at, 4,000. And let's bring it a bit closer. Hey, stop knocking things over. Crazy horse. And let's say that maybe 1,000 is the closest distance. So let's create 2 new variables, and we'll call this one near dist, and we'll make it a float, obviously. Sweet. Duplicate that and make it far dist. That's cool. We'll expose both of those, and we'll compile them, and we'll set the near distance default to be 1,000 and the far distance default to be 4,000. Okay, let's create a new function, and the first thing we're going to do is put a lerp in here. Actually, no, let's go normalize. So normalize to range is super cool. What that's going to do is take the two numbers, like the near distance and the far distance, and then the value of target distance. So you remember how that was updating and changing and printing. It's 1,000, 4,000, all that good stuff. The range minimum will be 1,000. The range maximum will be whatever our far distance is. And let's see if we go print string there. We'll do that. And we'll rename this to update. Let's go normalize distance. Okay, compile, save. In the event graph, we'll drag that one out and we'll go normalize distance. It's going to do that. But then actually what we want to do here is actually promote this to a variable, and we'll call this current distance alpha. This is between 0 and 1. Bam, 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 bam. Cut that stuff out. So all it's doing is normalizing that range and outputting another variable for us to use. So in the event graph, we'll have the current distance alpha. Get that, plug that in there. Plug it in. There we go. Bam, 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 bam. So it's at 0.7 right now. 0.5 as we get closer. And then, whoa, what's it doing there? It's going negative, but as I run away, it goes back to 0. Scriggity bam. Yes, yes, yes. Up to 1. Oh, it's going over. So it goes over 1 and it goes under 1. So what do we need to do with that number? What we probably need to do in normalizing the distance is after we normalize it to this range, because as I said before, it maps it to a 0 to 1 range. It doesn't actually prevent it from going above or below that, which actually can be really useful in some cases to not have that clamp on it. But in this case, we do want to clamp it. So it's a float clamp, and its minimum will be 0 and its maximum will be 1. Then we plug it into the distance alpha. So this number that we're going to use for other stuff will never get below 0 or above 1. Let me play again. 0.8. Let's just run away from the camera. 0.85, 0.9, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. It's creeping down. It's coming down. It's coming down. It's coming down. We're within 1,000 now, and it's claimed. Very, very good. Now, we've updated the distance, we've normalized the distance, but what might we also want to do with it? How are we going to use this alpha? Okay, so the cheapest thing for us to do right now, I'm going to make a new function, and I'm going to go update camera FOV. We're going to update the camera's field of view. So we're going to take in the current distance alpha. We're going to create another lerp, which is a linear interpolation between the two values. And we're going to take our camera component, grab that, and set field of view. We're going to plug that in there. Let's bring this down, clean it up a little bit so you can see what's happening. We're going to plug the alpha into the alpha of this lerp, the current distance, and we're going to let it drive that. So let's say, we want to promote it to a variable, and let's call it near field of view. And we'll leave that as a float. We'll duplicate and we'll call it far field of view. We'll make both of those editable. Oops, I don't need an event dispatcher. Delete you. Compile and save. And we'll plug that in there, near FOV, and we'll plug far FOV in there. So this is going to use the distance alpha that we set up before to drive the field of view of the camera. Now, right now they're both set to 0. So let's set the near FOV to, I don't know, 55. And the far FOV will set to something like, I don't know, 12 or something crazy like that. Hit play, running around, and if we switch to this camera, what we should see Oh, actually, no, I'm not calling that function. I just realized that just then. Update camera fob is not actually a part of this. So I need to make sure that I drag this in here and actually call that function. Might not be terribly noticeable at the moment, but actually let's make it even more obvious. We'll get the camera component and we'll get field of view. Pipe that in there and then we'll print that out as well. Compile, save, bam, bam. So currently the camera field of view is at 19, 20, 21, 22, 23, 24, 25, 30, blah, 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 blah. So it's getting all the way up. But because the camera's up in the air, I never get quite to 100%, I don't believe, although I sort of did before. But the best way to show this is to actually show it. So I've got a nice kind of wide view of the horse. As it's zooming off into the distance, you can see the camera zooming in on it. Brump, 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 brump. Oh, it fell down. And actually, what I might do is take this camera, lower it down to the ground a little bit, so that we can actually see what's happening. We have some depth cues in there, and I might actually duplicate this thing over here so that we've got another little bit of depth cue there, some stuff that we can see in the environment. No point having a cool camera if you can't see nothing. Hit U, and the horse is pretty much staying the same size on screen. Running behind the stuff. It's going to come back under here, but you see how that jolt there, where it started to blend into the new field of view as the object got closer. And if I go over here and I decide I want to run over the ramp there, so it's punched in to pretty much its final field of view. And yeah, that's pretty, whoa, we fell off the side. These are stupid holes. And that's pretty much how it works. We're interpolating the field of view, so it's at 12 right now, and it should, there you go, come in and start pushing it back as it gets closer. Cool. Cool, 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 cool. Now you could apply some latency in this camera update field of view. So you could have, what do we do? We want to, it's not a word, it's a, interp 2, I believe. So we want to interpolate it. Float interp 2. Here we go. So we can get the camera component, get its current, field of view. We get its field of view, and then, so we get the current field of view, and then we get the target one, which is the result of this lerp. We can drag off from delta time and get world delta seconds, and then we can promote a variable that is the FOV speed. Okay, and I guess we'll just set that to 1 for now. It's going to be a little bit hard for us to tell without something else happening or some like really super extreme change in the field of view. So what I might do is set the near FOV to like 100, which is like ridiculous, and the far FOV to 6. And I might even set its far distance to be something like 2000. So this is a really dodgy setup, but you hopefully should be able to see what the result is. And then obviously, let me clean this up a little bit. Drag this out. We've got the FOV speed going in there, and the return value for this will be the float interp. So this is going to interpolate those values over time. So I think with a value of 1, it's probably going to be pretty quick. So if I hit U, whoa. Okay. Alright, so it's getting closer, getting closer, getting closer. So you see how it's a little bit more smooth there? And it's actually still continuing to interpolate even as the horse has stopped. So it's just a way for us to kind of blend that out and make it feel a little bit smoother. So hopefully that's apparent in the video there, that that distance is, you know. Cool. Now we have a slight problem there where we're not actually looking at the part of the horse that we want. So in our event graph where we update the camera look at, we can actually, let's see. So without casting to this actor, it's going to be interesting for us to try and grab a particular component. No, that's not going to be good. Look, let's do this the slightly hacky way. So we'll get the actor location and we're going to add a vector to it. And let's make it something like 100 on the Z axis. So whatever the location of the actor is, we're going to add 100 to it. And that's just going to work for us because we're overriding it. Now, what you probably ought to do is have some method of grabbing the skeletal mesh or the bone or the socket or the component of the object that you actually want to have the camera pointing at in order to track it properly. But we'll make do with this. Alright, so horse is a little bit high in frame there. But as it gets further away, okay, so it's 100's probably a tiny bit high, but it's actually not too bad. And then as it gets closer, it works out fine. We don't really notice it too much. So we could probably make that exposed and actually adjust it in the inspector while we're running, I think. So let's promote that to a variable and we'll call it look at offset. Make it public, compile it, pluk. Make sure that we grab our look at camera, go into our details panel and find our look at offset, which is currently at 100. We'll hit play, hit U to look at the camera. We'll actually push the horse as far away as we possibly can. I mean, this is a combination of the look at offset and the field of view that we're using. So, where's look at camera? Look at camera. Let's make this like 80. Or maybe 70. Maybe 60. Yeah, 60. So when we come back out of play, we're going to have to reset that. I think you can hit K to keep the values that you've changed, but I don't really do a lot of stuff at runtime like that. Got our horsey back. He's running around, looking pretty good. And then as it gets closer, whoa, that starts getting nasty. So I probably want to have that far distance set quite a bit larger. Let's make it something, let's put it back to 4,000 and we'll make the far fall something a bit more realistic, like 12, and we'll see how that goes. Boom, looking pretty good. You see how we get quite fisheye when it gets close, which is not ideal. But then as it sort of starts to get away, we interpolate to it. Nice and smooth. So even when the horse has stopped, it's still going to be interpolating. And we can control that with this fob speed. So if I set that to something like 5, let's see what that does. Yeah, it's responding almost instantly. There's no blending really at all. There's a tiny little bit of blending when it comes to a stop. But not really. So we could even make this like something crazy like 0.5 and have it be really slow. When it gets close, yeah, you see the camera's still interpolating there, still trying to catch up. Cool. So let's try one last crazy thing. Let's go add camera roll. And this is cool. This is you wouldn't necessarily use this all the time, but we can actually take pretty much all of the stuff from the update camera fob and paste it in here because we're going to be using most of the same stuff. So we want to get the camera component and set relative. Let's get the relative rotation, and we'll unplug this stuff. We get the relative rotation, and then we want to do a rotational lerp. Do we? Or do we want to interp to rotator, finterp to? Actually, we've already got one there. So actually, we don't want an interpolator. We want a rotational interpolator. Interp 2. Okay, so we can frag that off. Let's duplicate the fob speed. Duplicate that and make it roll speed. And we can drag that over the top of this one to change that node. Plug the delta time and the roll speed in there. We get its current rotation. I don't think we actually need this lerp. I think this will be all we need. I'm doing this on the fly, so bear with me. And the target will be... Let's make a rotator. And... we'll have the... We'll frag those off. We want to make a max roll. And let's set that to something crazy like 45 or something like that. This is only going to work in one direction at the moment. So if it's close, it's not going to have any roll at all. As it gets further away, it will. So I'll plug this into the yaw of this one. We'll have the rinterp 2, and then we will set the relative rotation. So this is going to adjust the camera's rotation relative to its parent. Although I might need to do it on the local. Well, actually no, this ought to probably work. So let's see what it's doing. Okay. Oh, again, I'm not calling the function. We set the world rotation for everything. Yeah, but see, maybe it'll screw up because I'm actually setting the world rotation every frame. But then so maybe I need to set the actor's rotation. This is probably not going to work, guys, but we'll find out. Okay, and then we'll still have it print the field of view. Why not? Yeah, see, it's freaking out. It's trying to do both at the same time. So we're going to set the... So actually, what this should be is not set relative rotation. It should be add relative rotation. And then we're going to pass this in there. So whatever it is, we're going to do it there, compile it and save it. In the event graph, we're doing this after we've done the look at, so that should be okay. It's calculated all of this stuff first and then gone through to do the camera roll. Interesting. Interesting. No. Get its relative rotation. Let's remove the interp 2 on that one. That's because I got it in the wrong axis as well. So we're lerping between 0 and 45 based on the distance alpha. We're making a rotator. We're going to add relative rotation, but it's going to do that every frame, so it's just going to start spinning the camera like crazy. Intriguing. Yeah, okay. Well, alright, so as it gets further away, it's rolling to 45 degrees, which is kind of unsettling. But as it gets closer, it straightens out. So you can use this for kind of interesting subtle effects. Like if you've got cars that are driving around on your track, that you need to kind of whiz past the camera and you want to start kind of like Top Gear. Start with the fastest horse in the world. This steed knows nothing but power. It's rattling the back teeth. Something like that, you know. And yeah, so I'm pretty sure that you should be able to do the interpolation there. I don't know if that's necessarily how I had it before. Maybe that's screwing it up a bit. Yeah, it is screwing it up. It is screwing it up because it's getting the relative rotation and doing stuff with it. So let's just avoid that for the moment. I can cover that in another video, but suffice to say, if you wanted to smooth that out, you'd have to do a little bit of stuff to do with making sure the lookout was set first and then going through and, you know, cleaning this up a little bit. But there you go. We've got a camera that can track an actor, can zoom in and zoom out based on distance, and also do things like rotate. And the really important one here was update camera distance and normalize distance, because it gives us a 0 to 1 value that we can drive other things with, and that's really super powerful. So I guess let's put something in here. Let's create a branch, right? So this is going to allow us to determine whether or not we want it to look at the player. We'll drag off of the condition, we'll promote it to a variable and go look at player pawn, player pawn target. We'll expose that, compile and save. We'll set it to be default true over here, which it is. If that is true, then we're going to set it to be the player pawn. If not, it's just going to look at whatever we specify in here. So we need to make this public. So let's pick, I don't know, this little canistery thing as the target for the camera. So we've now got an available exposed variable. We can grab physics cube. Okay. So if I hit play and we move to that camera, it's going to target the horse. If I turn it off and I hit play and hit U, it's going to target the cube. So let me get my horse over here, and we're pretty much targeting it. Here we go. We'll hit U. Hopefully the horse should come in and hit it. Come on, horsey. Yeah! Yeah! So we can have it target other objects in the world, which is really cool. And you could create all kinds of logic that you want at this point to determine what it should be targeting. I mean, if it's not selecting the player target, you probably want to have a is valid in there, and then plug the target actor into it. If it is valid, then fine. If not, print a string saying, you know, no target. So if I do that now, we hit play, we hit U, it's going to look at the pylon thing. If I were to go in here and clear that and hit that and hit U, it's just going to default to looking at 0, 0 because it has no target. Error warning, access non-target actor. So we need to specify something in there. So I hope that this has been, this kind of went on a lot longer than I expected, but if you have got something out of it, if you enjoyed it, or if you have any questions, let me know in the comments. Feel free to jump in and subscribe or like or whatever the stuff you do on here is. I haven't really asked people to do that before, but I'm feeling motivated to make more of these. So if you like it, please let me know, and I'll be driven and motivated to make some more. All right, peace. Have a great day. Bye.